Hello everyone, welcome to the second video in the Iterator pattern class. And what I want to try to do is to solve the problem that we left at the end of the previous video. So your job was create a channel iterator class that allows me to iterate over a collection of channels. So your new class has to implement the channel iterator interface, and you need to do the implementation of the two methods that are inherited from the interface, but also any other construct that you have in there, whether it is a constructor or any of the attributes. So let's take a look at how we can approach that. So the first thing that I'm going to do is I'm going to create a new class that I'm going to call channel iterator. Now, the other thing that I know about this class is that I need to implement the channel iterator interface. So as soon as this is done, it's asking me to add the unimplemented methods, which I'm just doing. And surprisingly enough, my error in the channel collection class still hasn't disappeared. So my error is still there. Well, let's have a look at why. Well, as we can see, the constructor that I'm invoking in here receives two attributes. So that means that I need to implement in my channel iterator class that constructor that takes those two attributes. One of them is going to be the type, and the other one is going to be the instance of the list channel that I'm using, or that the collection is using. So let's do that. Let's go to the channel iterator, and let's say public channel iterator. And of course, we're going to define here my parameters, in this case, my type, which is defined as an enum, and then a list of channels that I'm going to receive as a parameter that I'm going to call channels. Of course, it's asking me for the import for the list. Okay, now it makes sense that if I receive those two things as a parameter, I should have them as attributes. So it only makes sense that is that way. So now that I have those parameters in there, so it makes sense to assign them. So I can say this type is equals to type, and this that channels is equals to channels. Great. Now, the other thing that I should implement in here is some sort of position marker. If we think about it for a second, in my iterator, in any iterator, I always am moving forward one position in each one of the iterations. So it makes sense that I have some sort of marker to know at what position of the collection I am. So I'm going to implement a position variable that is going to be an integer, and at the beginning of each instantiation, I'm always going to define that position as 0. So I'm always going to be starting my position at position 0. Okay, so now that I have my constructor and I save that, my error in the channel collection has disappeared. So now we seem to be ready to go. The next thing that we need to do is to implement the two methods hasNext and next. So let's start with the hasNext. The hasNext has to return true or false whether we have a new element to iterate over. Now remember, the fact that I have a new element in the collection, that doesn't mean that we have a new element to iterate over, because I need to keep in mind what is the type that I'm looking for. This iterator is going to allow me to filter only one particular or one specific type of channel. So what we're going to do is we're going to, first of all, catch the channel at the current position that we are from the collection of channels. And once we have that, we're going to assess what type that channel is. If the type is of the type that we're looking for, then we can return a true. But if it's not, then we need to move forward until we find one that is actually the type that we're looking for, or until we stop. So we say if C, the cat type, which is the method that I have given you for that, equals the type that I'm looking for, then I will return true. Now, we're not quite ready yet, but there is another situation in which I might return true. Well, if we go back to the enum could be English, Spanish, French, or all. So if my solution is all, I'm always going to return true if there is another element in there. Why? Because I'm going to keep moving forward all the time. So if the type that I have in the collection is equal to the one that I'm looking for, or the one that I'm looking for is equals to all, then I will return true. Now, if not, then I should move to the next position. So that means that if not, then my my counter should increment. Now, something else that we need to keep in mind is that if my counter increments, I need to do the whole checking again. Well, that means that then I need to wrap this up with a while loop. This is going to happen several times. How many times? I really don't know. It will really depend on the distribution of my types that I have in there. So I'm going to wrap all this thing up with that while loop. Yeah, we stick that in there. Perfect. Now, what would be my condition? Well, all of this is going to happen as long as my position is lower than the number of elements that I have in the collection. Because if I go over the number of elements that I have in the collection, then that means that the element that I'm looking for is not there anymore. So I'm going to do that as long as position is smaller than channels than that size. Now, just one more thing, just for code quality, it's not really necessary, but just for code quality, it makes sense to have this thing declared outside the for loop, or the while loop in this case, and then just instantiated in each time. That's just for good practice, nothing else. So if this condition is met, then I can return true. If not, I increment and I repeat. And I increment and I repeat and I increment and repeat until I get to the end of the array. And if definitely I don't find the element that I'm looking for, then I just return false. Does that make sense? Great. Now, the next thing would be to implement the next method. And the next method is going to be fairly similar. With the difference is that I don't need to increment the position. I will increment the position if I need it. But instead of returning true, I need to return the element that I'm at the correct position. And if I am returning the element, that means that I'm happy, then I need to move the cursor to the next position. So let's say, so we're going to say channel C is equal, let me just get rid of this as well. Channel C is going to be equals to my channels get the one and at the current position where I am. And then what am I going to do? I'm going to, in fact, return C. Now, if I return in C, well, my iterator has to move to the next position. So I need to do also a position plus plus. So my iterator needs to move forward. Now let's take a look from the client class point of view to see if this makes sense. So from the client class, we can see here that once I create the new iterator, I will pass the type that I'm looking for. In this case would be all. So this should list all of the available channels. So notice that to use my iterators, I need to call the hasNext method first from the base iterator, just to move the iterator to the inner position, or just to make sure to verify that it's actually in there. Once it is, if it is there, so we get the next and so on. So let's take a look at how this works. Now, the same thing is going to happen for the rest. In his case, I am looking for only Spanish, only English, and only French. So let's take a look at this. And there they are. So my iterator is actually working correctly. So all my available channels, when the iterator has been defined for all, in this case, then only the Spanish channel, when my iterator has been defined for the Spanish channels, only English channel, and only French channel. Now, this is a great tool because that means that if I'm doing some sort of search, the search can be encapsulated using my iterator. Now, this code, as usual, is going to be available on Moodle, so you can take a look at that until you feel a little bit more comfortable with it. Now, something else that you can do as an exercise is, if I call, in this particular case, if I call, I'll just show you here, in the channel iteration, in this particular implementation, I always need to call the hasNext method, because if the hasNext method is the only one that is actually putting the position at the position of the next element in my filter. So you see, in this case, the next method is only moving the position one position, but that next position doesn't necessarily means that is the correct element that I'm looking for. So this is assuming that the hasNext method is always going to be called before the next method is going to be called. So something that you can do is to change this implementation of the next method so it does that verification for you without needing to call the hasNext method. That's absolutely up to you. I'm not going to do it, but that's an exercise that you can try and give it a go. Now, some of the implications of this pattern is that it's really, really useful when you want to provide a standard way to iterate over a particular collection. It's been done several times, as I said before, in connecting to databases or in any of the collections. Now, you have a standard way, although internally the iterator might be using different things. As I mentioned before, the collection doesn't necessarily have to be a linear structure. It could be a tree, and then all the traversing of the tree is going to be encapsulated inside the iterator. From the client point of view, I only calling the next element, Now, the logic for the iterator is embedding the collection itself, and it helps the client program to iterate over them easily. So it's really, really useful and handy. Now, that is another exercise that you can do. You can implement your own, you can create your own implementation of a tree and implement the iterator pattern over it. Okay, guys, thank you very much for watching. that's it for this class. If you have any questions, let me know in the live class. Thank you very much, and I'll see you in the next one.